At the end of last month, Eric Dubay put out this video showing how he could measure the distance to the sun above a flat Earth. So let's have a listen.
Triangles played a crucial role in these cultures, particularly in the realm of astronomy. Ancient astronomers used triangulation, a method involving triangles, to measure celestial distances and chart the movements of celestial bodies. By observing the sky from different vantage points, they could calculate distances with remarkable accuracy, laying the groundwork for future astronomical discoveries. This work was part of their geocentric view of the universe, where Earth was considered the center around which celestial bodies moved above and over the Earth's flat plane.
Yes, Eric is right. Triangulation has been used to measure distances for thousands of years and even in astronomy. But is this going to support his claim that the sun is close above a flat Earth?
Simple trigonometric calculations could be made between two locations to determine the distance to the sun. For example, one location might observe the angle to the sun at 84 degrees above the horizon, and a second location observes the same angle to the sun of 84 degrees as well. Using an established baseline distance of 500 miles for our example, they could triangulate the distance to the sun from each observation point. With the distance between the two observers known to be 500 miles, trigonometry can calculate the distance to the sun. With both angles of elevation at 84 degrees, the formula shown here provides the distance to the sun from each baseline point of observation. This calculation would give each observer a distance of approximately 2,391 miles to the sun, far from what we are told by modern astronomy, where the sun is said to be millions of miles distant in the heliocentric model.
So let's take a look at how Eric did this calculation. So he starts with two known 84-degree observations of the sun with a 500-mile baseline between those observations, and of course the angle at the sun would be 12 degrees. Eric uses the law of sines to make the calculation. Now all of the angles of this triangle are known, and so is side C, which is 500 miles. So Eric either needs to make a calculation for side A or side B to find the distance to the sun for each observer. Eric uses side A, so he gets a correct calculation of about 2,391 miles for each observer. Now, Eric did not do this, but now that we have this information, we can also find the altitude of the sun above the flat Earth. And this can be done with the Pythagorean theorem for the shaded triangle on the right. Now, since we know the lengths of side B and C, we can use the formula A equals the square root of C squared minus B squared. And that gives us a sun altitude of 2,377 miles. Now, I'm sure some of you have noticed that Eric is mistaken to make the claim that 12 degrees of latitude distance equals 500 miles. And that's because 1 degree of latitude equals 60 nautical miles, which is about 69 miles. So 12 degrees actually equals 828.56 miles. Now, using the law of sines, that would give us a distance from each observer to the sun of 3,963 miles. Now, this gives us a sun altitude of about 3,942 miles, but this is not going to help Eric.
This method of using trigonometry to measure distance to the sun is far more reliable and repeatable than the random reasons and numbers given by heliocentric scientists over the centuries.
So what are the random reasons and numbers given by heliocentric scientists? Well, these are the estimations that Eric talks about, but let's be honest, trying to figure out a way to triangulate a distance to an object that is millions of miles away is not that easy. And what about the random reasons and numbers given by flat Earth scientists? Well, let's start with two video clips that are from Eric's 200 Proofs the Earth is Not a Spinning Ball.
Flat earthers throughout the ages, conversely, have used sextants and plane trigonometry to make such calculations and found the sun and moon both to be only about 32 miles in diameter and less than a few thousand miles from Earth.
Now, when I used Eric's numbers, the calculated height of the sun above a flat Earth was 2,377 miles, but in the video clip, he said the sun is less than a few thousand miles above the flat Earth.
Another proof the sun is not millions of miles away is found by tracing the angle of sun rays back to their source above the clouds. There are thousands of pictures showing how sunlight comes down through cloud cover at a variance of converging angles. The area of convergence is, of course, the Sun, and is clearly not millions of miles away, but rather relatively close to Earth, just above the clouds.
Now Eric has gone from a sun that is less than a few thousand miles above a flat Earth to a sun that is just above the clouds. Eric, do you even know how high clouds are? Because the highest ones are only about 6 miles. Now, commercial airliners fly anywhere from between 31,000 to 42,000 feet, which is between 6 to 8 miles. So is Eric really making the claim that the sun is below the altitude flown by commercial jets? I think somebody would have noticed that by now. Also, many flat earthers have claimed the sun is about 3,000 miles above the flat earth. Now, Eric is a big believer in the philosophy known as Zeticism. And Thomas Winship, the author of Zetetic Cosmogony, claims that the sun is approximately 3,000 miles above the flat earth. And he based this on an equinox sun being above the equator with a 3,000-mile distance to 45 degrees latitude north and south. And of course, the observed angle to the noon sun from those locations is 45 degrees. Of course, one thing that both Eric and Thomas have forgotten about is that if we're going to use triangles to measure the distance to the sun, then if this is true, this must also be true. Now in this video, Eric asks the question, how do sunrise and sunset work on a flat Earth? And of course, he claims it is due to perspective. Now here's a graphic that Eric used to explain how this phenomena works, but let's don't forget what Eric said about triangles.
Triangles played a crucial role in these cultures, particularly in the realm of astronomy. Ancient astronomers used triangulation, a method involving triangles, to measure celestial distances and chart the movements of celestial bodies. By observing the sky from different vantage points, they could calculate distances with remarkable accuracy, laying the groundwork for future astronomical discoveries.
So yes, Eric, I agree. We can test this with triangles and trigonometry and get very accurate measurements. If we know the height and the distance, we can calculate the observed angle with this trigonometric formula. The angle equals the arctangent of the height divided by the distance. And a calculation for a sun that is 3,000 miles away and 3,000 miles in altitude matches Thomas Winship's model, where the observed angle to the sun is 45 degrees. So here I've recreated Thomas Winship's model of the flat Earth equinox sun with the sun directly over the equator and observations from the 45th north and south latitudes. So again, if the triangles for the Winship model are correct, then this 6,000 by 3,000 mile triangle for an observation from the North Pole must also be correct. And when we do a trigonometric calculation for that triangle, we can see that an observer at the North Pole would see the equinox sun 26.7 degrees above the horizon. An observer on the opposite side of the equator from the sun would still see the sun at 14 degrees above the horizon. And if an observer went all the way to the ice wall, which is about 17,000 miles from the location of the sun, he would still see the sun at 10 degrees above the horizon. Even if the sun was 1,000 miles high, it would still appear to be about 3.4 degrees above the horizon from that ice wall location. Now, the only way to get that sun to appear to be on the horizon from that ice wall location is if we had that ridiculously low 6-mile-high sun. And this is because the calculation for that triangle would be about 0.02 degrees, which is about the same as the resolution of somebody that has 20/20 vision. So Eric, not only did trigonometry show scientists that the sun cannot be close above a flat Earth, scientists were able to figure out how the geometry for sun observation does work on a globe with a radius of about 3,959 miles, where 1 degree of latitude equals 60 nautical miles, or about 69 miles. And as this graphic shows, parallel sun rays from a distant noon sun on the equinox match the observed angles at each latitude. This is also true for observations to polaris from each latitude. So I'm sorry, Eric, you are mistaken. Triangles in trigonometry actually prove that we do not live on a flat Earth with a local sun.